Hello everyone and welcome to our YouTube channel. Today I'll be discussing a very crucial topic. And the name of the topic is scripting. So I said it's a very crucial topic. What did I mean by that? So scripting is what I mean by scripting is submitting a job to an HPC. So what happens is usually we do not work in the interactive mode. So we do work in the interactive mode. That's just for testing. Once we know the program is working for small values, we can change the values to a desired number, since in physics, that's what the HPCs are mostly used for. In physics, the numbers can range from 10 to the power 22, and especially in the case of nuclear and astrophysics, these numbers can be very large, for which the program needs to execute on. So in that case, running the program in an interactive mode is not very practical, because you are not going to sit in front of the computer and wait for it to produce the result. So what we can do instead is I can create a job script and I can submit the job to the HPC, and I can say that when this job finishes, create an output file with the output of the program and store it in the home directory. So in this video, I'll be talking about how we can create the script for this job submission. What exactly is this script? How does it look like? What all needs to be defined, etc., etc. So for today, I'll be talking about a simple C++ script. So most of the time we work with C++ program. So the script can be made for any language which the HPC supports. So currently for this, I'm working with C++. So this time we'll be looking at a C++ script. So this is a simple hello world program, nothing complicated. I chose this because this is a very basic program and it can be easily understood by almost any beginner. And since the program is not the focus of this session, that's why I stuck to the very basic of it. So I have include stdio, that's for input output. Int main, I am defining a for loop just so that I can, this is also quite unnecessary. We can just we could have just done a hello world print, but I did that so that I can show you variable outputs. And then this is the main, it's the lead of our video, the job script. So I have hash exclamation slash bin slash bash. What is this? So this is a identifier for Slurm. So Slurm is the management software that is used on the HPC. On the H1 that I will be working on, Slurm is the management software. And this is the identifier for Slurm. So this line remains unchanged and it needs to be added to every script. Next is hash sbatch. So sbatch, you can think of it like defining parameters. So sbatch means I'm defining a parameter minus capital N. Capital N means number of nodes. So minus N, I have written space 1. So that means I want one node. And then I have a hash sbatch minus minus N tasks per node. And what do I mean by that? How many CPU cores I require for this task. So whenever you submit a job, even if you are, let's say, not submitting a job, logging it to the interactive mode, interactive session, you still need to define how many CPU cores you would require for your job. So I'm doing just that. Currently, the HPC has maximum 48 cores available. So I have just written 48 here, but depending on your use case, if you are submitting very small programs like the one that I'm currently submitting, you can reduce this number to maybe 2 or 4 cores so that there can be a better resource allocation for others as well. Next, we have sbatch error. So what I'm doing here is I'm defining the name for the error file. So whenever you create a job script, you need to define these two terms. Why do we need to define output? Output is very obvious because that would be the name of the output file. I want this to be the name. And error, why? If let's say some problem occurs while the program execution, some runtime error occurs, so the output will be blank. But for you to find out what that error was, you need this error file as well. So that's why the error here. And we have job dot percentage j. So this percentage j will be replaced by whatever job ID the HPC assigned to our job, and dot err. So that will be the name for the error file. Similarly for the output file. Now I have sbatch minus minus time. Time basically means for how long I want this job to run. If this time is exceeded, then the job will automatically dissolve. Sbatch minus minus partition, that's mean which node I want to work in, and I have partition is set to standard. So standard basically means I'm covering CPU and high memory nodes, and I'm leaving out the GPU nodes. So this is pretty standard stuff. There's not much changes across any language that you'll be working in. But here's where the main part comes in. So we have CD. So what I'm doing here is I'm telling the system that the execution file is in this directory. So you need to go there and find this file. So if it is in the home directory, you can leave this line out, because by default it will search in the home directory. But if it is in some other directory, you need to add that here. Otherwise it will keep on searching and the program will not run properly. Okay, and finally we have the executable file here. So how will this executable be created? That is what I'll discuss in the live demo. So let's get to it. So I am currently connected to a HPC, Paramrudra HPC. And as you can see, this is after you log into it, you see this kind of details of the HPC. So we have total number of compute nodes, we have CPU only nodes, GPU nodes, high memory nodes, etc., etc. And this is for this is to start an interactive sequence. This is for showing the job status, canceling a job, etc. And we have to submit a job script. We have sbatch. Okay, so first let's clear this here. And currently I'm inside the login node of this HPC. And the program we'll be compiling, this is the program hello world.c, same as in the PPT. Let's compile. Since HPCs usually work on Linux systems, and this one also has Alma Linux inside of it, I can just type G++ and the name of the program hello world.c. It seems our hello world has some errors. Oddly enough, it seems like it is not reading these. Okay. was a very simple error. It since I copied the program from a Word file, I'll show you what happened as well. So as you can see, these quotation marks, they are not the ones that are used in programming. How they are different, you can see. So these are very tiny, small things that can affect your program. I copied this program from my Word file, from the PPT actually. And that was the issue we were having. See, it's compiled perfectly fine. And it should have created a .a file. Let's see, yeah, there's the a file. So instead of, let's clear this, compile it again, no issues, it will be the same file. And now instead of just running this file, I will execute this. I will run the job script to perform to execute the executable. So let's do s batch, and then I have C++ underscore job script.sh. Let's see, submitted batch job 45824. So if I do a refresh here, I should see let's check our job. Let's check our job. So -u. I'm gonna write my username. Okay, the job is completed. Yeah, here it is, output. So you can see it printed the all of the specifications of the HPC. Cluster name Paramprabha, Slurm job account IUAC, job ID, Slurm job name, job node list, RPCN. So that means it was allocated to this node, job user, job IUAC, and I have Slurm job UID 52096, partition standard, task PID, CPUs on the node, on CPUs. There were 48 CPUs on the node, cores basically. There are not exactly 48 CPUs. There are 48 cores on the node, and Slurm and task used 48. Okay, and it printed hello world, hello world, hello world. There was no -n in this, sorry, /n. So it just kept printing on and on. Okay, let's do one thing. Let's change this from 5 to, let's do 1. And compile the program again, G++, and submit the job script. Let's check. It is running. Okay, I think it must have executed by now. So it takes some time depending on the availability of the node that we requested. The job may take some time. And 45829, hello world. See, and we got 48 cores again and all of that. We see. So let's try changing the script once. Instead of 48, let's do 2, because that is also enough for our job. And let's see what happens. Actually, just do dispatch. There's not much that needs to be changed. Okay, so it is still searching for a node. So you can see, how do I know it's searching for a node? Because it says node list reason priority. And if you look at this one, if you look at this here, it says node list RPCN 041. So that means it's still searching for a node, but my job is in priority. And now it's finished. So I should be able to find it here. Let's refresh once. Yep, 5831. See, it used only 2 of the CPUs. So in this way, you can modify uh, the needs according to your modify the script according to your needs and the language you will be working in, and submit jobs to the HPC for it to perform. Remember that all the compilation will take place inside in the login node. Only the execution of it will be done via the job script. So you just need to keep the executable file there. That is it for this video. Thank you for watching.